Right, hello everyone. So it's 3 o'clock, so I should get started. Thank you all for attending. I'm here to talk about the top OpenID Connect and OAuth mistakes that have been found in production mobile apps. So my name's Joseph Heenan. I'm a senior architect at Authlete, and I'm also the lead on the OpenID Foundation certification program. So some of you might know me from there as well. My co-presenter is Amir Sharif, who's a researcher in Italy. The astute amongst you might notice that he's not here. Unfortunately, he couldn't travel at the last minute, so I have the honor of presenting his slides, which is always slightly unnerving to present someone else's slides, but hopefully I'll do okay and do them justice. So the outline for this talk, we're going to talk a bit about the background of OAuth2. We're going to talk about some of the implementation challenges. We're going to talk about the best current practices for OAuth2 in native apps. Talk about the compliance analysis that Amir did. Talk about a methodology that we hope will assist developers. And then we've got some conclusions as well on how things might be improved going forwards. So starting with the background. Mobile devices are everywhere these days, everyone knows this, and they interact with our sensitive personal info, lots of it. Most common way that's done in mobile apps is with OAuth and OpenID Connect, at least if you're looking at standardized mechanisms, and they're really key to the user security and privacy, so getting those right is really important. Again, probably a lot of people in the room already know this. OAuth2 is an authorization framework. It enables third-party apps to obtain delegated access to users' resources. It's not an authentication standard, and we have OpenID Connect that layers on top of it, and that introduces the ID token and the user info endpoint, which lets us get some information about users as well. Secure integration of OAuth and OpenID Connect. Within mobile apps, it's not a particularly easy task, at least not today. So some of the implementation challenges. The base standard, again, probably some people here will be very familiar with this, RFC 6749, the OAuth2 authorization framework that came out of the IETF OAuth working group. It's very much the basis of everything we do today, but it's certainly not the only standard you need to know. So we also have RFC 6750, which tells you once you've actually got an access token to access a user's APIs, it tells you how to actually use it to access the APIs. And then we've got the threat model and the security considerations RFC that goes alongside that. But unfortunately, that's not all you need to know. That's one of Amir's animations, it's brilliant. There are a lot of other standards, and you really need to know about some of these today to get OAuth and OpenID Connect implemented securely in a mobile app. But it really shouldn't be on individual developers to read and understand all this stuff, because they're not there to understand all this stuff. The developers just want to access APIs, get some nice data, and create an app that users want to use. So in terms of the things we see, there's a lot of known anti-patterns that are still used. And I'll explain some of these on the next slides, but things like usage of the implicit flow, the state parameter not being used properly, which means the app's vulnerable to cross-site request forgery. People store client secrets within native apps, which if any of you are familiar with native apps, you can't actually store secrets in them and expect them to be a secret. And a lack of PIXI enforcement, which again, I'll explain that in a slide or two. And when you get this wrong, it's bad news, literally. It hits the news sites. And you don't want to be in that position. It's never good. I mean, probably all of you heard of the big hack at GitHub where somebody got a whole bunch of access tokens and a whole bunch of people's source code was exposed because the access tokens let you access their Git repos. It's not something that should really be happening these days. We know how to avoid it, but it does happen, unfortunately. So let's talk about the best current practices for native mobile apps. These come from the IETF. It's a document that's about 5 years old now. It's known as BCP 212, which is not incredibly snappy. And for the purpose of today's presentation, there's really 5 recommendations in there that we're going to look at, and then talk about which mobile apps do and don't actually do these things correctly. So the first one is the recommendation is to use the authorization code flow and to not use a client secret. So this is a typical OAuth flow, and the reason you know this is the implicit flow is because it's got response type equals token, which means in the OAuth2 when we send the user to the identity provider is going to redirect the user back to the original app, and it's just going to pass the access token as part of the URL, which is not secure. There's all sorts of ways that can actually leak out. It might become part of the browser history. It might be vulnerable to access cross-site scripting. And this is something that was in the original OAuth2 standard, but it's been recommended that you shouldn't use this for at least 5 years now, but probably much longer, really. But so next recommendation we talk about from the BCP is using HTTPS claimed URLs or custom URIs. The idea with this is that, as I say, with the OAuth2 flow, you're redirecting to the identity provider, and the identity provider then redirects back to you. What you really hope is that when the identity provider redirects back to you, it does actually redirect back to you and not a malicious app. And by using a claimed HTTPS URL, there's a mechanism that the OS ensures that your app is the only one that can claim the URL, and it's cross-referenced with your website so that there's no way that other people can make that same claim. And if you don't have that in place, you can potentially have a malicious app that ends up with the authorization code. It can exchange that authorization code for the access token, and they're then able to access your users' data, which is what we're trying to avoid here. So the next recommendation is to use PXE. PXE is also the not very snappily proof key for code exchange standard, but what it basically does is there's essentially a session created in the mobile app, and we send an identifier to that session to the authorization server when we redirect the user to it. Then we get an authorization code back, which we then exchange for an access token. And when we exchange it for the access token, we provide a proof to the server that we're in the same session that was the original one that got the authorization code flow. So if you don't do that, then what we can see on the screen, the attacker manages to get hold of the authorization code, which again, it's passed through the browser. So there are various ways that it can leak. And then because in this case, we're not using PXE, the attacker can just exchange that for an access token, and they get access to your user's data. Again, that's the thing we don't want. That particular one's called a code injection attack. So the next recommendation from the BCP is that you use an external user agent. I appreciate at this point I'm just reeling off a whole load of stuff, but this is kind of setting up the context for the apps that then don't do these things. So the recommendation from the BCP is you use an external user agent, which on iOS would be something like an SF Safari view controller. That's sandboxed away from the application, so the application can't see what's going on when the user's actually inputting their username and password. The alternative, which is the bad thing to do, is that you just use a web view, and the web view is running within the context of the mobile application, and it means the mobile application's able to spy at anything that goes on in that view, which means they can steal the user's username as they enter it, they can steal the user's password, they can get the cookie after the user's logged in if it's an MFA type login, and that's not the kind of access we want the mobile apps to have. The whole point of OAuth is that the apps never get access to the actual user's credentials that would give them more wider access than the thing the user actually wants them to access and has authorized them to access. So yeah, using a web view may lead to the user's credential leaking. We'll now talk about the actual analysis that was done of the Google Play Store apps. So this was actually an academic paper that Amir and his team wrote and has been peer-reviewed and published and all those fun things. And if anybody wants a link to it, feel free to ask me afterwards. So what he did is he looked at the top-ranked apps in Google Play from February 2021 1 from 13 different categories. And he looked at their compliance with the BCPs and if they made insecure implementation choices. And then he also broke it down a bit and looking at if they were using an official SDK from the authorization server or not. He looked at which ones didn't follow the best current practices and which ones had other misconfigurations. The resulting data set had 57 apps, of which there was 63 different interactions with OAuth servers. Only 5 apps of the 83 were fully compliant with the BCPs. All apps that were analysed that were using Box, Dropbox, Facebook, Google, LinkedIn, and Yahoo were not compliant with all the BCPs. It's not a terribly good result. The most overlooked BCP was the one that Amir calls BCP flow in the paper, which is people either using the implicit flow or using the code flow with a client secret when it's recommended to use it without a client secret. And yeah, you can see the numbers there. So yeah, breaking that down into a bit more detail, there were 52 apps that were sending client secret, 26 of which had them in plain text. The little bit of code you can see on the right-hand side, which I appreciate might be a bit small for the people at the back, is just the result of decompiling an Android app. And if your eyesight is good, you can see that the client secret is just there. It literally takes 30 seconds to extract it from an app. You can't secure secrets in a mobile app, so you shouldn't try. Well, that's not entirely true, but that's a very different talk. Yeah, and there are ways to avoid using client secrets in general, but again, we're getting down into the weeds when we talk about that. And the other thing that we found was HTTPS scheme misconfiguration. So only 2 of the apps were actually using HTTPS claimed URLs, and 1 of those didn't have them configured correctly. So again, not a great result. So breaking this down in terms of which apps were and weren't using official SDKs, so 35 of the apps appeared to be using official SDKs. 2 of the apps weren't compliant with the BCP because for reasons that we have no idea, the developers had managed to remove Pixie when it was present in the SDK. You hope they had their reasons, but I don't know what they were. 15 apps weren't compliant because the IDP, the actual authorization server, didn't support Pixie, so there's not much the apps can do when that's the case, unfortunately, or because the apps were using client secrets. And there are another 13 that weren't compliant because they were using an embedded browser and they were just using the implicit flow. And then if we look at the apps that were using unofficial or just weren't using an SDK, 48 of those apps, 37 weren't compliant because they're using a different flow. 40 were using an embedded browser, which is not recommended. 46 weren't using Pixie. Yeah, it's not good numbers. It's, you know, only 2 apps were actually using Pixie here, and it's really not that difficult to actually implement. So again, one of the outcomes of Amir's paper was they tried to look at how they could make this easier for developers. What they came up with is something that they call MID Assistant Plugin. It's basically a wizard-based approach for helping the app developers actually configure things. It's based on two steps. So there's a database that is populated with the actual details of the various authorization servers. So you put the Amazon, Google, Facebook server details into the database, hopefully by someone that knows roughly what they're doing. And then the user interacts with the SDK. There's a series of wizard questions that just guide them to providing the configuration details that are necessary to integrate the app with that server. So, you know, providing the basics of a client ID and so on that are fundamental to this process. This is actually a bit of code that runs in Android Studio as a plugin. And it just guides the developers through collecting that information, and then it spits out a project that has something called OAuth, which is an open source project that actually implements some of the best current practices. And it uses that OAuth SDK, it configures it correctly, and it's just ready to go. The user just has to actually hook in the few lines of code necessary to make things actually do what the app developer wants the app to do. And that's open source, and it's available on GitHub, and the link is there. But I mean, that's still in early days. So yeah, conclusions, and there's a few of these. Yeah, the numbers clearly show that the majority of native app developers are not focused on OAuth security. My presumption is that's because they're just very understandably taking the easiest path to just getting things working, because their aim isn't to implement OAuth to an OpenID Connect securely, or they just want to get an access token back and access the user's resources and do all the fun things that the app is actually meant to do. That's never really going to change. The thing you have to change is to make the easy path the one that's actually secure, so give them an easier way to actually get the secure path implemented, which the MID assistant is one of the ways. OAuth 2.1 may help eventually. If you're not familiar with OAuth 2.1, it's essentially taking OAuth 2. It's not really making any changes, but it's removing the bits of the spec that we know people shouldn't be using anymore. It's solidifying many of the specs down to a single document so that you don't have to hunt through a whole maze of RFCs, and it's making editorial improvements to the text so that the standards are actually easier to understand. So in the long term, that's going to make life much easier for the people that need to actually understand the standards. But given that we're 5 years on from the native apps BCP, and we've just seen that the majority of the apps aren't actually following the BCPs, if you just follow that pattern, you have to assume it's going to be years before OAuth 2.1 makes any impact on improving things in the actual kind of real world. I think there's many opportunities for authorization server vendors here to improve the situation. Certainly recommending the use of AppAuth is certainly something I think I would like to see authorization server vendors doing. AppAuth, it's an open source SDK. It implements the best current practices. It's pretty easy to embed into your app. And it's fairly easy to configure, even easier if you use MID Assistant. And that avoids you really needing to understand the guts of the protocol. Some vendors have their own SDKs. Some of those are not in a good shape, so they should either improve them or integrate AppAuth into them potentially, so that they're using the open source bit that already does the standards well, and they're just wrapping it up into the SDK that does the bit that specializes to them. So, a Dropbox SDK could just be AppAuth plus some wrappers for the actual Dropbox APIs to make it nice and easy to actually get the documents. It would be great if the authorization servers actually contributed to the development of things like AppAuth and MID Assistant. They're open source projects, as is the case with pretty much every open source project. They're short-handed, they're not perfect in some areas. There's areas that they could be improved to make things easier and actually really make life easier for the developers that are trying to use them. And it's the authorization servers that it's the authorization server vendors that benefit from these SDKs being available and easy to use, because it means they'll get less support questions. People will be able to get up and running with their servers much quicker, and that saves. It costs money, but it saves money in a different place. It'd be really great if any vendors in the audience could have a good critical look at their documentation and see if they're actually following the latest BCPs, because Amir and myself did a quick review of various documentation, and there's quite a lot out there that's not been updated for a good 5 years or more and does not really express best current practices. Possibly sometimes deliberately, because it's just trying to follow a basic tutorial. But then it doesn't, the end of the tutorial doesn't say, hey, okay, that's the basics, here's now how to do all this stuff securely, which is a bit of a shame. And the final thing that you can do in some cases is to do server-side enforcement of the BCPs. So, for example, for Pixie, you can just reject requests if the app isn't using Pixie, and then the developers have to implement it. They don't have a choice. And I think we are starting to see that happen, but really enough people aren't doing that yet. Yeah, I will take questions in a second. So, yeah, that is the last slide. I am talking with various vendors to try and improve things. We're trying to come up with an industry-wide approach to kind of make this better, make it easier, make it faster. So please do email me or talk to me afterwards if you would like to join in with that. And yeah, we now have time for questions, so let me hand you a microphone.
Just wondering about mechanisms for detecting embedded user agent. Is it user agent sniffing, or? Essentially,
yes. I don't know if everybody heard the question. The question was, how can we actually detect the embedded user agent? So if people are using web views, it's not the easiest thing to detect. You can definitely do it with user agents sniffing. It is unfortunately easier to forge the user agent header, so then you're really looking at adding a bit of JavaScript as well. That there's various things you can detect in JavaScript that will clearly show if it's an embedded view or not. And for example, Google do that quite well. They pretty much banned people very effectively from using web views several years ago. So, yep, next question.
I was just wondering, in a, let's just say, greenfield scenario for mobile apps or apps in general, is there a legitimate reason to use dynamic client registration or client secrets generally?
Good question. I mean, client secrets you just really shouldn't be using in native apps these days, unless you are registering them dynamically. There are actually lots of good reasons to use dynamic client registration in general in mobile apps if you're going for some of the more secure use cases. Because if you use dynamic client registration to register a per instance client, so each mobile device actually has its own client rather than being one shared across the app, then that actually gets you some good security properties. You can register a key that's specific to that client, and then if you use private key authentication, you're not actually ever transmitting a secret on the wire. And you can also embed that key into the mobile device's hardware security module so that it's not extractable. And, so yeah, by using DCR, there's a whole load of good security things you can get. And I think George possibly talked about that earlier. Any other questions? Oh, yep, one there.
Yeah, so is there a good practice for securing the dynamic client registration endpoint? So what's preventing me from going to create a client for Facebook, let's assume?
That's an excellent question. It does vary. If you're an authorization server vendor, there's some very good techniques these days. For example, you could use app that's a terrible word, app attestations. So for Google, that would be a safety net assertion. For Apple, it would be a device check assertion, and that actually shows that the request is coming from a genuine instance of your mobile app, and that's very hard to forge, and then that means that you know that the DCR request is coming from a genuine version of your app, and that gets you the security.
Well, is there something preventing me from having a proxy in the middle and catching their attestation and using it myself?
Well, that's what we rely on TLS for mostly.
Oh, okay.
So yeah, you still have to do the basics correctly.
But most proxies will have, you can enable TLS. Diddler, for instance, you can have a TLS enabled on it, and it can decrypt everything for you and encrypt it back.
Yeah, so you'd be looking there at doing something like TLS certificate pinning, so that even
so you'd pin?
Yeah.
Oh, okay.
Yeah, that's kind of the more standard underlying security things that you have to get right, even if you're not using OAuth. Any more questions? No, I think we're done then. Thank you very much, everyone.